Hey everyone! So as promised, I put together a quick little video in order to explain the rest of the exercise that you need to turn in by this Friday for lab. So last class or during lab, you guys went out, you took a survey or gave out surveys based on environmental attitudes as well as transportation. Now I believe everyone finished their graphs already for transportation, and that was all based on bar graphs. If you haven't answered those questions in exercise 6, be sure to complete those because those are also due on Friday. Now exercise 7, we've already done most of the legwork. At least we've already collected all the data. I've already compiled it all for you. You just need to complete the graphs and answer a couple questions about those graphs. So I wanted to go over just a couple quick slides just as a background to scatter plots. So as I introduced last class, here are a scatter plot, and kind of as the name suggests, it's a bunch of points scattered around. Now the reason we make scatter plots is if we have two continuous variables. Remember, we had continuous and categorical variables. Continuous is when your variable is along a scale 0 to 100% or precipitation anywhere from 0 inches to 5.23 inches. So whenever you have a continuous variable, here we see a quiz average, which again is all across a scale, versus their final exam score. So two continuous variables. And that's when we make a scatter plot, and that's what all of those environmental questions that you guys receive survey responses for are. It was a continuous answer. What percentage of paper do you recycle? How many times have you gone to the farmer's market? So we're going to be creating 3 different scatter plots. Now scatter plots, a way to interpret them. So bar graphs, you can look at a bar graph, see which bar is higher or lower than another one. We also talked about error bars or confidence intervals, so we statistically knew what was happening. Now scatter plots are a little bit different. The result or the resulting trend is that we can say these two variables are related. So here we have a scatter plot between GPA and the hours per week of TV watched by these students. Now the line you see here is not what you guys will be drawing. You will only be drawing these points. The line is just outlining that general trend. We see that students that have higher GPAs are not watching as much TV per week. It kind of makes sense. You can kind of extrapolate on that, say, oh, well, it's probably because of XYZ. They're always busy doing something else. They're not watching TV, they're studying instead. The biggest thing, though, is that we cannot say, when looking at a scatter plot, that watching more TV causes GPA. Scatter plots are not cause and effect. We're only saying that they're related. More than likely, it's not actually the hours per week of TV that are affecting the GPA. It's probably studying. Students who study more get a higher GPA. Well, students who are studying more aren't using their time to watch TV, so it's not TV directly that's causing this lower GPA. So that's a very big note. You can definitely make associations, you can relate them to each other, but it is not cause and effect. There's a very common saying that you may have heard before, that correlation, which is what you see, a correlation is relatedness between two variables. Correlation does not imply causation. It is not saying it's cause and effect. So definitely keep that in mind, especially when answering your questions about scatter plots. So how to make a scatter plot. And you've seen these pictures, kind of self-explanatory, but I'll give you a crash course anyway. So first place I'm going to head to is Blackboard, which obviously you've already been to Blackboard because you're viewing this video now. So here I am in Blackboard on the announcements page. Head over to course content, and then you see week 5 graphing. And by the time you're watching this video, this will probably look a little bit different. But I have 2 attached files. One is the graphing data. This is in an Excel document. The second one is this graph paper image. I believe all of you guys took graph paper home with you, but in case you didn't or in case you needed more, you can open this up, print it out, and use that instead. So it's there if you need it. So I'm going to open up this Excel sheet. I actually already have it open on my computer. And here you go. This is very similar to what you already saw in class. So first I'll show you down at the bottom there's 3 tabs. The environmental data, which you're going to need for scatter plots. And then if you needed to revisit anything with your bar graphs, I also have the transportation raw data, and more importantly for you, I've summarized the data for those graphs. But again, if you've already done your graphs, you don't need to worry about these tabs. So the environmental data is what you're going to need to complete exercise 7. Now the actual graphs you make, so if you flip to page 53, if you read question 2 at the very bottom, it says to choose, make 3 graphs looking at the relationship between any 2 of the survey questions. So here we have 6 columns, each one representing one of those survey questions. And you can choose whichever 2 you want to compare. You just do that for 3 times. So you're going to choose 3 pairs of variables. So I'm going to choose a pair. I'm going to choose one variable being the percentage of paper someone recycles, related to or looking for a relationship between that and the numbers of farmers markets visits that they make. Now your very first step after selecting which 2 variables you want to study is to determine what is the independent and dependent variable. You have to do this with every single graph you make. So remember, independent variable, what is causing a change in the dependent variable? So I'm going to look at these and I think, well, I think if someone visits farmers markets more, is going to cause that person to recycle more paper, because maybe they're more attuned to agriculture and world problems and local sustainable growth. I don't know, but that's the best relationship that I can think of. So I've identified my x-axis, so I'm going to say x, which again is the independent variable, so independent, and that equals a farmer's market. And you don't need to write this out, I'm just showing this as an example. My y-axis, which is my dependent variable, is going to be percent of recycled paper. Now that you know what your axes are, you can go ahead and graph them. So I'm going to open up some graph paper. I said that my x-axis is going to be, I apologize for this very bad writing, farmers, say farmers market. Make sure you are labeling your axes. So we have farmers market and we have percent, we're going to say percent recycled, but you should have more complete axes titles. Percent recycled. So now that I know what's going on each axis, then I can go ahead and figure out and plan my axes. With all of your graphs, they should be stretched, as in you should be using as much space as possible. Well, the easiest way to do this is figure out what is the minimum and maximum numbers of your data set. So I'm going to take a look. Now I'm going to do kind of a shortcut to figure out what the minimum and maximum number is. Instead of looking at each individual number, figuring out what's largest, which you definitely can do, I'm going to highlight this data set. And you can see down here in this taskbar, it actually tells me my minimum is 0 and my maximum is 52. So I'm going to write over here my minimum of 0, and then I'm going to do a max. I'm going to round it to a nice even number, max of 55. Now if you do not see the minimum and maximum, just right click on this toolbar and it's actually an option. You can just check the minimum and maximum. Alright, I'm going to do the same thing for percent recycled paper. My minimum 0 and my max is 100, which I was kind of expecting anyway. So we still have this 0 down here and 100. So now I have ensured that all of my data will first of all fit on this graph, and second of all, it'll be stretched out as much as possible. For this farmer's market axis, I don't want to do 0 to 100 because that means about half of my graph paper won't be used. Definitely want to stretch it as much as possible. I'm going to fill in some intermediate values. This does not need to be perfect. You do not need to count perfect numbers of squares. You can kind of round it. I'm going to think this will be 28-ish. That's about half of 55. And now you're just going to start plotting the points. So I know when I had 0 farmers markets visits, we had 40% recycled paper. So here's 0 farmers market, and this is around 40. All right, next point. 1 farmers market visit, 90% recycled. So 1 is going to be around here, and 90. Got 1 and 85. And so on and so forth. Now there's about 57 data points. You do not need to make it perfect. You should put all of the points on the graph, but again, don't waste your time counting individual squares, making it absolutely perfect. It should be in the roundabout general area though. Don't, if it's supposed to be 80 and you put it around where 50 is, your graph's not going to be very accurate. Now at the end, I'm going to just kind of make up data. I have no idea what this relationship is going to look like. But here you see a general declining trend. So you could posit that, oh, by going to a farmer's market more, these people tend to recycle less, and you can answer questions about that. If you see points all over the place where there's no general trend, that's exactly it. There is no general trend, that those two variables aren't related at all. So again, you're going to choose 3 different pairs. So you might do percent recycled, number of farmers markets. You might do, let's say, importance of environmental issues in percent recycled paper. You might want to do outdoor activities and camping trips. It's whatever 3 pairs interest you the most. Now, if you are interested in doing these graphs in Excel, there is a second video you can watch. If you'd rather do it by hand, that's totally fine. It is completely up to you. You won't get points off either way. If you're familiar with Excel, I recommend doing it in Excel, but if you're not great with Excel, don't worry about it at all. It doesn't need to be perfect if you're doing it by hand, but you should have that general trend. So again, here's your graph. You're going to be making 3 of these, and then you're also going to be answering the questions that go with this. Now the questions that you need to do, or I should do it differently, the questions you do not need to do, I'm trying to limit how much work you're doing outside of class. So you do not need to do question 1. This is all for exercise 7. You do not need to do question 3D. On page 54. On page 55, you do not need to do question 4D. And on page 56, you do not need to do questions 5D or question 6. You also do not need to actually complete the environmental biology survey on page 57. If you have any questions, please send me an email. This isn't due until Friday during class. If you have me as a professor for the lecture, you are more than welcome to turn this in early. If you are not in my class, but you're around Germantown, more than welcome to turn it in during my office hours. I'm available Monday and Wednesday in the morning. So with that, I hope you guys have a fantastic weekend. Please let me know if you have any questions. Thanks.